The third console generation unlocked all sorts of new potential for adventure, from the hidden secrets of Super Mario to the new layers of vertical discovery in Mario 3. But for me, none of this compared to the first time I experienced four-directional movement, playing Dragon Warrior and other games like it. Suddenly, there was an entire world available to explore, and I didn't just have to go there via a linear path. Four-directional movement gave the promise of choice, the promise of freedom, the promise of adventure. Last tutorial, we looked at how to use the tile map system in Unity to quickly build your own worlds. In this tutorial, we'll see how to move your player in 4 different directions and add colliders so that you can interact with your environment. As a special bonus feature, we'll also show how to swap out your placeholder graphics with character sprites to make your game a little more individual and unique. Let's get started. So first off, I'm going to head up into my hierarchy here. I'm going to hit the arrow by my grid in order to close up all of my different layers, and I'm going to create a shape that will represent our player. You can begin by right-clicking over here in the hierarchy, go down to 2D Object, Sprite, and I'm going to use a circle as my player. If we zoom in, you'll see that I now have a player character there, and I'm going to rename them as the player. One thing you'll notice is that my player currently disappears behind some of the objects in my world, and I don't want that happening. The way to fix that is to head over into your inspector, and in the sprite renderer, pick a higher order in layer than all of the other objects. I'm going to pick a nice high one like layer 10 for now. My player will now appear on top of all other objects. Now the next thing that I want to do is I want to make it so that my player will actually have the ability to move. So to do this, I'm going to head into my assets folder. I'm actually going to take my tile palette here and just put it in behind, as I won't be needing it for the next little while. And we're going to create our first script. To do that, just right click in your assets window, head up to create, C# script. I'm going to call this one player controller, as it will control things like my player's movement. You can then open it up in Visual Studio. All right, now there are a couple of different ways to handle movement in Unity. I'm going to be using rigid body physics simply because I like the way they work and I feel like the collisions are nice and natural. First thing we're going to need to do is head down below our class and declare a couple of variables. First one is just going to be a public integer, which will be our movement speed. And we can set that inside of Unity later on. We're also going to need to make a reference to our rigid body. Remember, a rigid body is how Unity handles physics. It adds gravity, and we can apply forces and that sort of thing. And so we'll make a public rigid body 2D. Make sure that you do make it 2D. And I'm going to call mine player RB. Now that we've declared our player RB, we can actually head right back into Unity. I'm going to click on my player, and I'm going to actually add the player controller right now. Now when I add the player rigid body, you'll notice now there's a box here for speed. Let's just put 5 in there for now. And there's also a spot for rigid body, and it says none because I don't currently have a rigid body attached to my player. So let's add that. Now that we have a rigid body, we can take that and drag it into that box. Now, if I were to hit play right now, you'll notice that my player character simply falls right off the earth, which is not the effect that we want. So make sure to take your gravity scale and set it down to 0 right off the bat. You can now head back into our script and actually get this player moving. So the first thing we're going to do actually is create a public. And this is going to be a float. Remember, a float is just a floating point number, which is any decimal. And we'll call this one horizontal input, H input. I'll also create another public float called vertical input. Down here now in our update, we can actually define those. So my horizontal input is going to be equal to input dot get axis. And the axis we're going to be checking is horizontal. Now just to explain what's going on here, input simply checks the keyboard and other inputs that you have for your computer and looks inside of them. Get axis will check the different axes, so it could be the X, the Y, or the Z for inputs, and horizontal is actually a pre-programmed input that Unity has inside of it that will check the left and right keys and also your A and D keys. And we can actually manually map different keys onto those later on if we like. But now our H input will get a number that is between -1 if you're pushing to the left and 1 if you're pushing to the right, and assign that to H input. So we'll now have a value. Now we want to do the same thing for vertical input. All right, so Unity will now be tracking whether or not we're pushing left or right or up or down. Now we need to just take those values and actually cause them to make our player move. Now to do this, we're going to refer to our player rigid body, and specifically to its velocity, and we're going to set that velocity equal to a new vector 2. Now, vector 2 is simply just a 2-coordinate system, so it will have an x and a y value. So I'll put my bracket, and our x value is just going to be, and remember x is left and right, so this is horizontal, will simply be our h input. So we're going to move to the left or the right based on whether I'm pushing left or right. We'll multiply that times speed. We can now put a comma, and now we get the chance to put in our y input, which is vertical. So vertical input times speed, and then a semicolon to end that up. Now at the moment, if we were to run this, we would have just a little problem, and that is that our update function is called once per frame, and frame rate varies depending on the performance of your machine and also on what exactly it's being asked to do at any given moment. So we can sometimes get a jerky movement where if the frame rate dips, our movement goes slower, and if the frame rate's doing just fine, it can go faster, and high-performance machines will be smoother, and we don't want that. We want to have nice, smooth movement. So we're actually going to head down below our update function here, get below the brackets, and we're going to create a new function here called fixed update. Now, fixed update runs exactly 50 times per second. So no matter how your machine is performing, it will run at the same clip all of the time. And we're just going to take the actual movement here because that's what we want to be nice and smooth, and we're going to paste it into our fixed update. We can now save that and head back into Unity. All right, because I've taken off gravity, you'll notice I'm not falling off the world anymore. And when I push left or right, my player is moving left and right. If you look over here in the inspector, you'll actually notice on horizontal input that when I push to the right, that number goes up and it accelerates starting low and then eventually getting up to 1. And the same thing with -1 when I move to the left. I can do the same thing with moving down and up, and we've got some nice movement. If you would like to be able to move more quickly, you can change your speed. If I move this to 10, for example, my player is significantly quicker. That's a lot faster than I would like him to move, and so I'm going to keep my speed down around 5. Now, there's still a little bit of a problem in that when I walk around my world, you'll notice I can walk over rivers and trees and that sort of thing, and we definitely want to fix that. Last tutorial, we added colliders into our tile map. You'll notice that when I click on water, it has a tile map collider, and there are green squares on all of my water that make it so that it can collide with other objects that have a collider. However, at the moment, our player does not have any sort of a collider, and so he's not detecting collisions. So if we head down here to add component, I'm going to add a circle collider, 2D, since I am using a circle for my player. You can edit the collider by clicking here, but if you're using Unity's shapes, it will automatically already be sized to your player. It's actually all you have to do. Now when you play the game, you'll find that as you move, you bounce into other colliders and cannot pass through them. Now we've still got some problems in our game. You'll notice that my giant world I created to explore is actually unexplorable. When my player goes off the map, he really does just go off the map. And so we need to create a camera follow script that allows our camera to move with our player, but we will do that in the next tutorial. Now, using this sort of placeholder art is a really common practice in game development, as it allows you to get your world set up, practice game mechanics, check out code, and that sort of thing without the arduous process of creating a lot of artwork that you might not even use in the end. That said, if you've already got your own art, or you just can't handle having a circle as your main player, it's really easy to sub in other sprites. So first off, if you click on your player in the hierarchy and look over in your sprite renderer, you'll notice this sprite box here, and you can simply drag in another sprite in order to sub out the circle for your character. So if you would like to for example, have Link in your game, you can drag him into the sprite box, and you'll notice right off the bat a small problem. Link's very small and very blurry, simply because he's a low-resolution sprite. Now this is an easy fix. If I click on the actual sprite in the assets here, there's a couple of changes I can make. First, by changing his pixels per unit, and you'll notice Link is 16 by 16, so I'm going to try that. And clicking apply, he will suddenly get much larger, and he more or less fills in a square in the game. He's kind of blurry though, and in order to fix this, we just need to change our filter mode. It's currently set to bilinear, which is designed to smooth the edges between pixels, but we don't want a filter. You can click apply and he's looking better. There's still a little bit of discoloration though, as some of the browns are doing some strange things, and I can fix that by changing my format from automatic to RGBA 32-bit. There we go. And with just that simple little change, I now have the ability to walk around my world and explore as Link. Or I could explore the world as Terra Banford from the Final Fantasy series. Or if you're a fan of the Earthbound series, you could go around exploring as Ness. It's up to you really how you would like to set up your character, but I encourage you now to go ahead and give it a try.